In this video, I'm going to do several problems that have the directions determine whether each pair of lines are parallel, perpendicular, or neither. I know when I'm thinking of determining if lines are parallel or perpendicular, I need to think about their slopes. So I need to find the slopes of the line and be able to compare their slopes. And I know if I put the line in the form y equals mx plus b, the slope-intercept form, I will be able to read the slope right from the equation. The slope will be the coefficient of the x term. So I come down to my first set of equations. One is already in the form y equals mx plus b. So I know its slope is negative 5/3. My other equation is not in the form y equals mx plus b, so I'm going to go ahead and solve for y so I can put it in that form. So I have the y term here. I want to get rid of this constant by adding 4 to both sides. Now I have 3y equals negative 5x plus 4. And then I need y by itself, so I'm going to divide by that coefficient of 3. And I'll get y equals negative 5/3 x plus 4/3. So my slope for this line is that coefficient of x, negative 5/3. When I compare my slopes, I can see the slopes are the same. And that means I have parallel lines, because parallel lines are lines that have the same slope. They never cross. Let's look at another example. This next example is the set of equations 4x plus 2y equals 5 and 3y equals 6x minus 12. Neither of them is in slope-intercept form, so I'm going to do that as my first step. So on this one, I'll subtract 4x from both sides because I'm trying to get the y term by itself. I'll have 2y equals negative 4x plus 5. And then I will get rid of the coefficient by dividing everything by 2. I'll get y equals negative 2x plus 5/2. So on this equation, the slope equals negative 2. Over here, I'm going to solve for y. I already have the y term by itself, so I just have to divide everything by 3. And I get y equals 2x minus 4. So my slope in this case is 2. So I compare those two slopes, and they're not equal, and they're not negative reciprocals, so I say neither. Okay, it's not parallel or perpendicular. It means the lines will cross, but they won't cross at a right angle. Okay, let's look at this last example. Two equations. The first one, I'm going to go ahead and isolate the y by subtracting 8x from both sides. And then I'll divide everything by that 2. So for the first equation, the slope equals negative 4. And on my second equation, I don't really want the y on the right-hand side, so I'm just going to switch the order here and write 4y equals x minus 7. Because with an equation, I can switch those two sides and it should still be equal. Then I'm going to divide everything by the 4. And I'll get y equals x over 4, and that's the same as 1/4 x minus 7/4. So in this equation, the slope equals 1/4. So now I'm going to compare these two slopes, and these two slopes are negative reciprocals, because one is the reciprocal of the other, and one is negative, one is positive. And when I have negative reciprocals, I know I have perpendicular lines.